All right, welcome everyone to day 22 of Infinite Code. The final few days remain. We are live currently doing this on Twitch over at twitch.tv/turkeydev, so feel free to check me out there. I've been doing all of the ones that coincide with my streams on stream as they come out. So we got just over 30 seconds to go. Fingers crossed again that today goes like yesterday, I can actually solve it. I would be very, very happy if I get at least 1 star in every day. I don't know if I'll go back to day 19 or 20. 20, I don't know. Maybe I could do 19, 20. I don't know if I want to spend more time doing those, but I don't know. At any rate, code is all set up here. We got our base code going, day 22. The text input here, and then our base code. Just waiting for the question to drop here in 3, 2, 1. Let's do it. It only takes a few hours of sailing on the ocean raft for boredom to sink in. Unfortunately, you brought a small deck of space cards. You'd like to play a game of combat, and there's even an opponent available, a small crab that climbed aboard your raft before you left. Fortunately, it doesn't take long to teach the crab the rules. Before the game starts, split the cards so that each player has their own deck. Your puzzle inputs, then the game consists of a series of rounds. Both players draw the top card, and the player with a higher value card wins the round. The winner keeps both cards, places them at the bottom of their own deck so the winner's card is above the other card. This is war. If this causes the player to have all the cards, they win, the game ends. Okay, so this is just war. This arrangement means that the player's one's deck contains 5 cards with a 9 on top. Player's 1 deck, okay, with 9 on top and 1 at the bottom. Player's 2 deck also contains 5 cards with 5 on the top, 10 on the bottom. Okay. Okay. Once the game ends, you can calculate the winning player's score. The bottom card in their deck is worth the value of the card multiplied by 1. The second card from the bottom is worth 3 times 10 plus 2 times 9 plus... Okay. So once the game ends, the winning card is play the small crab in a game combat using text just dealt. What is the winning player's score? Okay, so it's literally just, this is war. This is war. Okay. So let's start this up. So let's load this up by just string by line on input strings. Okay, and what we need to do is we need a list of integers. This is going to be the player's deck, new array list here, and then we're gonna have another list here. This is gonna be the crab's deck. Okay, and then we need to do a boolean load player cards equals true. So we just need to do a check here if this is not really needed, but if s dot starts with this, we just set load players cards equal to true. Otherwise, if it starts with player 2, we set this to false. And then otherwise, we do a check here. We do an integer parse int on s, and we get int card. And then we just do a check here. If we are loading the player's cards in, we do player's deck add card. Otherwise, we do the crab's deck add card. Okay, so now we've loaded all the cards in. We have the 2 decks. So now we just need to do a while loop. While player's deck dot size is greater than 0, and crab's deck dot size is greater than 0. We're just gonna do the brute force method. There might be a special math way to do this quicker. Whatever. Okay. So we're gonna do int player card is gonna equal player's deck remove 0. So we're gonna take the top cards off the deck. Crab's deck. So we're taking top cards off the deck, and we're gonna do if player's card is greater than the crab's card. Do one thing, otherwise the other. So if the player's card is greater, we then do the player's deck, add the player's card back, and then player's deck, add the crab's card back. Otherwise, we do a the opposite. We do the crab deck, but we do it flipped because we always add the higher card back first. This will go until one of the decks is empty, and then we'll do here is if the player's deck dot size is greater than 0. We just need a list of integer. This is gonna be a list. This is gonna be cards to count. New array list, and so we'll just do cards to count. Add all of the player's deck. Else, I don't know why I copied that. Else, we do cards to count. Add all of the crab's deck. And now what we need to do is we need to do what the question is asking, which is this logic, which is you can calculate the winning score. The bottom card is worth 1. Okay. Okay, so we just need to do for int I equals 0, while I is greater, or while I is less than cards to count dot size I plus plus. And so we just need to have a long total 0. We're gonna do total plus equals cards to count get I times cards to count size times or minus I. Is it plus 1? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. No, minus I. There we go. And then we can just do lap total. And that should be part 1. Right? Please be right. Let it build. Oh. Else if S is empty. If it is empty, actually we can just do else if it is not empty. Do this logic. Run it again. We get this as our answer. Be right. Yes, I'm happy with that. That was really quick. Cool. All right, so there's part 1. Part 2 now. You lost to the small crab. Fortunately, crabs aren't very good at recursion. To defend your honor as ref, you challenge the small crab to a game of recursive combat. Recursive combat still starts by splitting the cards into 2 decks. Then the game consists for the same K. Then the game consists of a series of rounds with a few changes. Before either player deals a card, if there was a previous round in this game that had exactly the same cards in the same order in the same player's deck, the game instantly ends in a win for player 1. Previous rounds from other games are not considered. Wait. If there was a previous round in this game that had exactly the same cards in the same order in the same player's decks, otherwise this round's cards must be in a new configuration. The player begins the round by each drawing the top card of their deck as normal. If both players have at least as many cards remaining in their deck as the value of cards they just drew. If both players have at least as many cards remaining in their deck as the value of the card they just drew, the winner of the round is determined by playing a new game of recursive combats. Oh my, otherwise at least one player must not have enough cards left in their deck to recurse. The winner of this round is the player with a higher value card. Chat. What? As in regular combat, the winner of the round, even if they won the round by winning a sub-game, takes the 2 cards dealt at the beginning of the round. This just went from 0 to 100 really quick. During a round of recursive combat, both players have at least as many cards in their own deck as the number on the card they just dealt. The winner of the game is determined by the curse. Player 1 draws the 3 card and player 2 draws the 7 card. This would occur if player 1 has a... If player 1 draws... There's no 3 card. Good job. I think they missed the 3 card. Wait. During a round of recursive... If both players have at least as many cards in their deck as the number that they just dealt... For example, player 1 draws the 3 card and player 2 draws the 7 card. This would occur if player 1 has at least 3 cards left and player 2 has at least 7 cards left, not counting the 3 and 7 cards that were just drawn. Oh, this, okay. What? Wait. So nines, they don't have nine, so they both need to have that many cards. 3 and 7, 1 and 10, 9 and 8, 5 and 2. 1, okay, so it's not there. So 6 and 4, 4 and 3. So then you play a sub game to determine the winner. Oh. And we need to keep a hash map of all of the previous scene? Bro, okay. I sort of get this now. Okay. So we need to do a public Boolean play play game. Sure. We're going to take this, put this into here, so it's going to be who won. So we need the list of integers. This will be the players deck with then a list of integers of the crabs deck. I'm trying to figure out how I'm gonna do this in my head too. This is not working out at all. Okay, so we can call play game. Okay. We can just return player's deck size is greater than 0. So this is going to be Boolean. Okay. So we're going to do Boolean player 1, and it's going to equal play deck or play game new array list player's deck new array list crabs deck, and we're going to check this. We can't count all the cards here. Oh yeah, we need to be able to count all the cards we get back. List integer, wow, integer player part 1, player part 1, and then we're gonna need crab part 1. Okay, so there's that. So now what we need to do is we need to play this out until we get the end. After the game, the winning player score is calculated from the cards they have in their original deck using... The winning player score is calculated from the cards they have in their original deck using the same rules as regular combat. In the above game, the winner is 291. They have in their original deck. Is that 291? Well, okay, so we're going to use this as our input. Chat. Like, literally, this is on the next level. Also, I didn't switch, sorry, I didn't switch this over real quick. I meant to be on this screen for people to actually see my stuff. So play game part 1, and then we're gonna need a play game part 2. Okay, play game part 1's easy. So now we're gonna need player part 2, crab part 2. So now we're gonna need play game part 2. Okay. So the way this is going to work is it's going to be the exact same thing, but what we need to do now is we need to check if player's card is less than or equal to player's deck.size, and Crab's card is less than or equal to Crab's deck.size. If this is true, we need to recurse down and play a game. By subgame determined. Okay. We need to then recurse into a subgame using we just need to know Boolean player 1 is going to be equal to play game part 2, new array list of the player's deck, new array list of the Crab's deck. So the player wins. Hey, what happens? Wins round 9. The player 1 won. Oh, so they keep the cards. Oh. I see. Okay. So what we do here is we do if the player 1... I see. If the player 1, we have to do this. So either way, it's the player here. Otherwise, we do this, but this is now the Crab's deck. Okay. Does this work for input? Okay. I see. Does this work for the example input? Out of curiosity. Okay, so what we need to do is then, oops, don't close that. I'm getting all sorts of confused here. Okay, so we play part 2, we do the player 1, we do this exact same thing. Cards count is new, total there, lap, K. I got 306. 306. Oh, well, we need it to be on the original. $306.93. On the 291 of the original deck. Oh, because I'm still doing part 1, part 2. 286. 291. What? 7562. Oh, because it's not in the right order. Okay. All right, did we just put this? I don't want to. I'm like torn because I don't want to, but at the same time, all right. What's the format here? All right, so it's going to be. So we need to know our depth in this. So we're going to need to know int depth here. So I'm going to call this. We're going to start it at game 1. So we're going to do a system out print line. You do this depth, okay, and then you have a nice break here. Let's just mimic what Eric has for us in the debug. All right. I'm just trying to get these diffs right. It's fine though. So this is saying 4-3 instead of 3-4. Oh, so it doesn't matter. So it always adds the winner in first. I thought it added in. Okay. So if the player wins, it always adds the players in first. So does that fix it? We need to get what? 3. Oh, I thought it. Okay, I thought it said the higher card. I don't know. Oh, maybe it's referring to. Anyways, I think there's part 1 said the higher card, and I just interpreted that there. There we go. Okay. Back to our input. This probably won't get our input because we don't have the check for infinite recursion. Right. Okay. Yeah, well, it's the winner's card. So the winner's card's always higher in part 1, but part 2, yeah. So that's why. Okay. Anyways. All right. We can get rid of these. I don't want to get rid of them. Let's just comment them all out. This is going to get messy. In case I need to come back to these in a second. So now the only thing left is to keep track of all the decks and prevent our infinite recursion. So we need a, what is it, the case? The case is, before the game, before either player deals a card, if there was a previous round in this game that had exactly the same cards in the same order, the same player's decks, the game instantly ends in a win for player 1. So it's only this game. So what we can do here is we're going to need a, oh gosh, we can just stringify this. Yeah, tie goes up, which means a tie, which goes to player 1. It's not a hash map. It's oh no, it's hash map. It's hash map. We're gonna do a hash map here. String, and we're gonna do string. I'm gonna do what I did last time when I did a hash map, which is just gonna be just stringify these lists and dump them into here. This is gonna be just the cache or the previous decks, new hash map. And so what we're gonna do is every time after we, or every time before we pull a card out, we're gonna do previous decks. Nope, not here. If previous decks, I didn't spell deck right. Nice. Dot contains key, which is going to be the player deck to string. Nice and easy. And then, and the previous decks gets player deck to string equals the crab deck to string. Nice and easy way to store a deck into our system for caching. So if either of these occurs, it goes for player 1, right? We just return true because the player wins. Otherwise, we do previous decks, put player deck to string, crab deck to string. Let's see if this fixes our problem. And no, does not seem to fix our problem. Because it's only this game, right? Hold on. Before either player deals a card, if there was a previous round in this game that had exactly the same cards in the same order, the same player's decks, the game instantly ends in a win for player 1. Right, okay. So either we're running too slowly, more likely something's wrong. So unfortunately, this is not a part of the example output, is this code here, so I can't figure this out from that. Shorten them up a bit, but also just prevent a bunch of two strings. Okay, so give me civilians in the win for player 1. Let me just make sure this is being called. How about this? Let's just make sure that we're getting a tie. Because if it's never outputting a tie, then there's a problem. Oh. Hello. What? Hi. That doesn't sound right, though. Oh, it was right. Oh, I was just doing so many two strings, I guess it got really slow. Hey, we did it. That was very anticlimactic. Okay. Let me clean this up. Good. All right. So for day 22, what we did is for part 1, essentially we get to read in all our inputs, just doing some parsing to get which person is the cards are being loaded for, load each person's cards into their deck into a stored list here. And then for part 1, we go through as we play a game. Basically, the game or the problem today is essentially just war. If you've ever played war, they call it combat here. But the game is war, where you just flip over your top card of each deck. Whoever has the highest card wins those cards. They go back into the winner's deck at the very bottom. And you just keep playing, keep doing that until one player wins. So in this case, we do that exact same thing. While both decks have a card size of greater than 0, we just pull the top cards off each deck, compare them together. Whoever wins gets those 2 cards, making sure we always put the winner's card on first, or putting it into the bottom first before the loser card. And we just keep repeating that process over and over and over until we get one of the decks having a size of 0, in which case this round ends. We do some, we just do the kind of conversion math here that asks for the results or the inputs in for our finished problem, and then we're good there. So that's part 1. And then for part 2, it gets a little more complicated because it's the same game, but there's a recursive step in the fact that whenever you flip over a card, or whenever both people flip over a card that is lower or equal to the size of their current deck size, the game goes recursive and goes into it using the deck that is currently there, the deck minus the one that's flipped over, goes into a recursive game that gets played out, and then whoever wins that is the one that actually wins the cards, not the normal whoever's card's higher. So that's the recursive step to it. The biggest thing is to get the recursion working, but then also have the anti-recursion detection system, where if you get a deck that is already, or if you get 2 decks that have already been seen before in their order, all the same, then you need to stop. The game is a tie, it's going to recurse forever, and then you need to return true for the player winning, because the player wins all ties. And that's probably the only tricky part about part 2, beyond comprehending the question, because recursion just by nature is difficult, at least for me it's difficult for me to understand at first. But beyond that, it's again just same thing as war, just with an added recursion step. And yeah, so there you go, day 22 of Advent to Code. Hope you guys enjoyed. I'll see you guys all tomorrow for day 23. Peace out.